let's continue where we left off. So we need to find particular solutions now. This is slightly different because what I'm doing is I'm taking my general solution, which has my answer, my capital F of x, my antiderivative plus some constant, but a particular solution is solve for that constant. Solve for c by getting a point. So if I am not given an additional point on my graph, I can't solve for c, and we call it a general solution. I'm interested in finding a very particular solution, which means I need to be given a point on the graph. So let's look at an example. I'm going to give you a differential equation. So let's pretend the question said dy dx is equal to 3x squared minus 1. And let's just say I said that f of capital 2 is equal to 4. And I'm going to say, well, find y equals f of x. That's how the question would be worded, okay? Well, how do I know I'm taking an antiderivative? Well, the question is giving me a derivative and asking me to find the original function. So I know I have to reverse that derivative out of there. So I'm going to say, okay, well, the antiderivative of dy dx with respect to x is equal to the antiderivative of 3x squared minus 1. So the antiderivative of this is capital F of x. I'm reversing the derivative process, or just getting my y back. What is the antiderivative of 3x squared? Well, I know that is add 1 to the exponent, x cubed, divide by that same number, and the 3's are going to cancel out. What's the antiderivative of 1? Well, that's x, because if I take the derivative of x, I get 1, plus my arbitrary constant. So we call this my general solution. Now they gave me an initial condition, so that will allow me to solve for a very particular solution. When x is 2, the y is 4, so I'm going to say, okay, well, what c value solves that for me? Well, 4 is equal to 8 minus 2 plus c. 6 plus c equals 4, so c equals negative 2. So my particular solution would be capital F of x equals x cubed minus x minus 2, and that would be the solution to that differential equation. I'm going to call it DE for a differential equation, and it's just asking you to find the original function given the derivative. I give you a derivative, you get me back to where I was before I took that derivative. Another one, let's find the general solution of this. How do I know that I'm doing antiderivatives? Well, I've been given a derivative and I want to solve for the solution, which is asking me for my original f of x. So I'm going to do the integral of f prime of x with respect to x of both sides. With respect to x. Well, what is the antiderivative of a derivative? Well, that means I just go back to my original function. I'm taking an integral, which is the reverse process of a derivative. It just gives me back what I start with. How do I do the integral of 1 over x squared? Well, I have to turn it into power rule. I get x to the minus 2 dx. I add 1 to the exponent, divide by that same number, plus my arbitrary constant. So capital F of x, my antiderivative, is negative 1 over x plus c. So now, that's my general solution. How do I know they're asking me for a particular? Well, the question asked for a particular, but they're also giving me an initial condition. So when y is 0, x is 1. So I solve for c and I get c is equal to 1, and then I just write my answer out. My particular solution is minus 1 over x plus 1. Now, sometimes in questions you'll have to solve motion problems. So we talked about me giving you a position function. You take a derivative to get velocity. You take another derivative and you get acceleration. In this section, I would give you acceleration. You would do an antiderivative to get to velocity, and you can do another antiderivative to get to position. So sometimes they will make you do that. Now here, they tell you that a ball is thrown up with an initial velocity of 64 feet per second. So at time 0, my initial velocity is 64 feet per second. I also know that the initial height at time 0, my position was 80 feet. They want me to find the position function. So I'm given acceleration. I know the acceleration on Earth due to gravity is negative 9.18 meters per second squared. And I want to get to position by taking two antiderivatives. Now, why is this question weird? Because my acceleration due to gravity in feet per second, because this was actually coming out of a US book, is negative 32 feet per second squared. This is no different than your negative 9.81 meters per second squared, just a change in units. So I want to do an antiderivative of this function to be able to get my velocity. So how do I do an antiderivative? Well, what's the antiderivative of negative 32? There's no variable there, so I just throw the variable in, minus 32t. The derivative of minus 32t is minus 32 plus an arbitrary constant. So my velocity is negative 32t plus c. My initial velocity is 64. So they've kind of hidden the initial question or the initial condition in the question for me. So 64 is equal to minus 32 times 0 plus c. So c is equal to 64. So my velocity function is negative 32t plus 64. Now, if I want to find my my position, I need to do one more antiderivative. So my antiderivative of velocity is position. I take the antiderivative of the right-hand side with respect to t. So this would give me minus 16t squared. I add 1 to the exponent, divide by that same number. Let me actually show that out a little slower. So minus 32, I add 1 to the exponent, divide by the 2, plus 64t. But now, because I've integrated, I need to add another constant of integration that's different. So I'm going to call it d. So s of t is equal to minus 16t squared plus 64t plus d. And they give me an initial condition. The initial position is 80. So now I just sub that in to solve for d. So 80 is equal to 0 times anything is 0, plus 0 times anything is 0, plus d. So d is equal to 80. So now my initial position is minus 16t squared plus 64t plus 80 is my final answer. In the next example, I'm doing a second derivative. How do I find the first function? I want to find f, and I'm two derivatives away. So what do? I take an antiderivative of my second derivative with respect to x, and the antiderivative of 12x squared plus 6x minus 4 dx. Now, to do the antiderivative of this, I add 1 to the exponent, divide by that same number, plus I add 1 to the exponent, divide by the same number, and then I add to the exponent, divide by that same number, plus an arbitrary constant. So I get 4x cubed plus 3x squared minus 4x plus c, and this represents my derivative function. Now, if you look at the initial conditions, I don't have a derivative initial condition. I have two original function conditions. So what I need to do is do one more antiderivative to get my original function. So the antiderivative of f prime of x dx will be the antiderivative of 4x cubed plus 3x squared minus 4x plus c with respect to x. So I add 1, it's all power rule, add 1 to the exponent, divide by that same number. That 4 in front gets carried along for the ride. Add 1 to the exponent, divide by the same number. The 3 gets carried along for the ride. Add 1 to the exponent, divide by that number. The 4 gets carried on for the ride. What's the antiderivative of c? Well, that would be cx, because then the derivative of cx would be c, plus another arbitrary constant, which is d. And the antiderivative of f prime of x is f of x. So here's my original function, but now my original function is written sort of as a general solution, and I need a very particular solution, so I'm going to sub in my initial conditions. Now you'll notice I have two unknowns, and I have two conditions, so that's going to be kind of like your grade 10 substitution elimination to help you solve for those two unknowns. So 4 is equal to 0 plus 0 minus 0 plus 0, because 0 times anything is 0, plus d. So that tells me right away that d is equal to 4 from that first condition. From the second condition, I get 1 is equal to 4 times 1 divided by 4 is 1. 3 times 1 divided by 3 is 1. 4 divided by 2 is 2, so minus 2, plus c plus 4, because my d was 4. So 1 plus 1 is 2, 2 minus 2 is 0, so I get c plus 4 equals 1. So c equals negative 3. And I just go and sub those in, clean up my function, and that would represent the answer to my problem. X to the fourth plus x cubed minus 2x squared minus 3x plus 4. If I were to take the derivative of this twice, I better get my original starting function, which was the original one I was given. Let's quickly do that and make sure. So I'm going to kind of just call it a check. So one derivative would be 4x cubed plus 3x squared minus 4x minus 3. The second derivative would be 12x squared plus 6x minus 4. And if you look at my original question, that's exactly what I started with. So I know that this is the correct answer.